going for some non-linear estimation process. So we will be using SPLINE regression. Okay, so as in the last correlate, when you just have some scatter plots, I just saw that you guys have a scatter plot on expenditure and income, and you guys were just seeing that there is a positive trend. Okay, and from that scatter plot you can say that there is a very good correlation, a positive correlation, and moreover there is a very good positive trend. Okay, now suppose the most contradiction part was that you guys saw that there was a very good positive trend. Okay, there exists a positive correlation between income and expenditure, but when you felt it into a scatter plot, you guys saw what? You guys saw that the value of correlation coefficient was very low. When you guys go for a correlation analysis, you got that the value of correlation was very low. Now what is the reason behind that? Okay, so this was correlation. If I go beyond that, if I go for a regression, so what was the reason behind it? Okay, just let me show you something that suppose just you guys just give me some answers. Okay, just normal answers. All of you guys have saw, all of you are aware with scatter plots and all that. Suppose in this case the scatter plots are looking like this. This is y and this is x. Can you tell me what type of correlation they are having?
Yeah, positive correlation.
Fine. What type of trend there is? Positive trend.
Positive trend.
What should be the slope of the regression line?
Positive.
Very good. Means if I go for a regression, y equals to alpha plus beta x plus u. Okay. So what should be the value of beta? What should be the value of beta?
0 point something.
Okay, it should be greater than 0. Okay,
Yeah.
it should be greater than 0. Fine. So you guys got that there is a positive correlation there, and moreover the value of beta is greater than 0. Now suppose this is your regression equation. This is your regression equation. Now tell me that what if the correlation, the scatter plot looks like this? What if the scatter plot looks like this? What type of relation do we have? Positive, negative,
I
or
think in that case that will be 0.
are you sure it will be 0?
Spurious regression.
Spurious regression, are you sure? No, I am not going for a regression. I am just telling you what type of relation there exists between y and x. What kind of relation?
Yeah, near equal to 0.
Near equals to 0.
Yes.
Okay. Now, if I fit a regression line, y equals to alpha plus beta x plus u, then what should be the value of beta?
0.
0.
You guys are telling that there is no relation between
X and
x and
Y
y.
at all.
Okay. Are you sure about that?
I think so.
No. The thing is that all the time this doesn't fits well. The main thing is that when we fit a regression, okay, when we go for a regression, we just go for some scatter plots, and after checking the in the previous data set what you have seen right now. Okay, so you have seen that there is the scatter plot was looking like this. Just let me draw for you.
Positive correlation and the
Positive.
value of the
Yes,
correlation coefficient was 0.37.
this was look like, it was in look like in this. Okay, and positive correlation, and there was a concentration in this part. Okay, and in this
Yes.
part it was rising. The main thing is that always your regression, when we think about regression, when we think about alpha plus beta x plus u, we always think that if beta is greater than 0, our regression line should be looking like what? Our regression line should be looking like a upward sloping straight line. Fine. And from here, This will be our regression line. This part is alpha and the slope is beta. Okay, this is the thing we know. But what if what kind of regression line is that? Then what type of relation? What is the Gauss Markov theorem tells us? What is the assumption? There is an assumption in the Gauss Markov theorem. We used to prove that. Blue estimators. What is the full form
Yeah.
of blue? Best
Best linear
linear
unbiased
highest
estimator.
estimators. So we use a term linear. We use a term linear. So this is a very critical assumption. You have a data set. You doesn't know that either there is a linear either we are estimating the problem and it is linear in nature or not. We have a data set. Suppose we have a data set of y and x, and if we go for that and we see that sir, I think there is a linear, we go for regression. We directly go for regression. When you go for regression, what you assume? There is a linear relationship between y and x. There is
Why?
a linear relationship between y and x. But that does hold true for all the data sets? No.
No.
That does hold true? No. So before going to a regression, a person should perform two things. A person should perform two things. What we miss out? The first thing is that first go for a scatter plot. First thing is that first go for a scatter plot. First visualize the scatter plot. If my scatter plot looks like this, suppose looks my scatter plot looks like this. So we can just easily say, sir, there is a linear regression, there is a linear trend between y and x. We can go for a linear regression. Yes, sir, because there is a linear upward trend. This is linear line. If you fit the regression line, this will be looking like this. So we will fit a linear line, sir. We will fit a linear line and the regression line is linear, and so we go for a linear regression. But what if your scatter plots doesn't look like this and your scatter plot looks like this? What if your scatter plot looks like this? What if your scatter plot looks like this? You can say that there is a linear regression or not. You cannot say that. You cannot say that. You can never say that. Your regression is, suppose, how do you interpret beta? Suppose I am writing you a line y equals to 0 0.5 plus 0.6x. What does it means? If x changes by 1 unit, y changes by how many units? Y changes by how many units?
0.6 unit.
0.6 units. But does it hold true all the time? Does it hold true all the time? Because your regression,
No.
when you have gone for a scatter plot, your scatter is looking like that. Your scatter is looking like that. So does it hold for all the time? No. Because if when you are going for a regression, your coefficient is coming like 0 0.6, and you are interpreting that if x increases by 1 unit, y increases by 0 0.6 unit. But you haven't gone for a scatter plot. You haven't gone for a scatter plot. You haven't shown a scatter plot. You haven't visualized a scatter plot. Until and unless you are visualizing a scatter plot and you are getting the data like this, so how can you interpret? How can you go for a linear regression? That is very wrong. In this case, what we do basically is we go for non-linear estimations. We go for non-linear estimations. Non-linear means, suppose have anyone heard about Kuznets environmental Kuznets curve or Kuznets inequality curve
Yes, sir.
in your UG days? You have heard about Kuznets curve. So how that curve was looking like? The curve was looking like this, inverted U shape. Inverted U shape. I am writing like a bell shape, but it was like a inverted U shape. Okay. What does that mean? That means when x increases, y also increases. It reaches to an optimum maximum point, and after that, as x increases, y decreases. This is the basic explanation. So, can you say what will be the slope of this part? What will be the slope of this part? What will be the slope of the top part? What is the slope of the top part? It is always exactly equals to 0. It is always exactly equals to 0. Do you know that the slope becomes 0 where it changes its curvature? Okay, so I am
Yeah,
not going in.
maximum.
Yeah, maxima, global maxima, local maxima, I am not going into mathematical economics so far. Okay, so the thing is that the most important thing is that my regression line will always look like this. or always look like this, that doesn't matter. My regression line may look like this, may look like this, may look like this. Suppose I am giving you an example. Okay, suppose in the y-axis we are measuring, suppose we are measuring our marks score. I will be using this data set only. And in the x-axis we are measuring my IQ, my IQ. Okay, so when you have plotted this scatter plot, you are getting like this, you are getting like this. The scatter plot is like this. How can you tell that there is a linear trend? What is the nature of the correlation between score and IQ from the scatter plot? What is the nature of the correlation? What is the nature of the correlation? Can you say? What is the nature of the correlation between score and IQ from the scatter plot? Are you getting?
Zero.
Yes, it is zero. Are you sure? Is it zero? I don't think so. Because if you view the diagram properly, if you fit a trend line, then it will be a positive. It will be something like positive. But there are some parts. Yes. Why you told zero? Because you cannot actually determine, sir. There are some points where IQ is very high but the score is low. And there are some points where the IQ is very low but the score are high. Yes, for that you told zero. That is why you told zero, because sir I cannot
Yes,
identify,
sir.
I cannot identify the exact relationship between score and IQ, because there are some parts. Suppose I am dividing the IQ, suppose I am sorry, I am dividing the IQ, it is something like 20, it is like 50, it is like 100. So the pupil with 20 IQ, there are some pupil with 20 IQ whose scores are very high. There are some pupil with 50 IQ whose scores are very low, and there are some people with 100 IQ whose scores are high as well as on an average. So how can you determine a regression? If you go for a regression, y is your score and x is your IQ, how can you go for a linear regression then? We used to go for a linear regression, but that is very wrong. We used to go for a linear regression, but that is very, very wrong. That is very totally wrong. So what is that? We go for non-linear estimations. We go for non-linear estimations. Non-linear estimations means, suppose, what does your, I am going again with the environmental or the inequality Kuznets curve. What was the inequality Kuznets curve telling us? That we measure inequality in the y-axis, and what we measure in the x-axis, we measure GDP. We measure GDP. Okay, we measure GDP in the x-axis. It was looking like this inverted U shape. That means as GDP increases, as GDP increases, my inequality also increases because the curve is upward sloping. But after a certain point of time, reaching to its maximum position, as GDP increases, my inequality falls. So what should be the regression equation for this? Can you tell me? What should be the proper regression equation? Suppose your GDP is inequality is y and GDP is x. Can you tell me what should be the? Can anyone tell me that what should be the proper regression equation for this? Anyone? Just have a try. What should be the regression equation for this? No one. No one from the group.
Sir, like parabola type.
No, no. What should be the regression equation? Just you like y equals to alpha plus beta x. What should be the regression equation in this case? I am just telling. Yeah, Orpon, Shushmita, Gulsanara, and Shreya, Moua. What should be the regression equation in this case?
But it is not linear, so it is looking like parabola.
Okay,
So
parabola. But how can I write the regression equation?
yeah, x square is equal to something plus
Uh,
4
I,
alpha y.
so I can write y equals to alpha plus beta 1 x1 plus, sorry, x1 I do not have to give because only I have the variable x. So beta 1 x1 plus beta 2 x square means what should be, can you now interpret from this inverted U shape what should be the value of beta 1? It will be positive or negative? It should be positive or negative?
Positive.
Positive. Why?
Because they are in the first quadrant. I mean,
Exactly, exactly. So as x increases, what is your x? GDP. As
yeah,
GDP increases, your
the
y,
inequality also increases.
exactly, your inequality also increases. But what is x square? Suppose this is 20 and this is 400. So this is x square. This is 20. You are measuring, this is 20 and this is 400. So this is x square. So what should be the value of beta 2? Positive or negative? What should be
Positive.
the sign? Positive or negative?
Positive.
Positive. So if x2 also, x also increases, then inequality increases or falls?
Increases.
Increases. In this part it is falling. In this part it
Yes.
is falling. So what should be the sign of beta 2?
Yeah, so
It should be
negative.
always negative. It should be always negative. So we fitted a regression model where our beta 1 is the coefficient of what? X. But when x is in, it is in the initial form. I am measuring x up to this. This is in the initial form. But x square means what? The square of this 20 square. So 20 square will be what? 400. So in this quadrant, and in this quadrant, in the first quadrant, when you are just having the, when the GDP is increasing, what you can interpret as GDP increases, inequality also increases, so the beta 1 sign will be positive. And in the
Yeah, but
second quadrant, what will happen? In the second quadrant,
it will
if
be negative.
it will be negative. Why? Because if the GDP increases, then inequality falls.
Yeah.
Is it clear? Is it clear to all? Is it clear to all?
Yes, 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 yes.
Others? Yeah, the others. Shushmita, Moha, Gulsanara, Shreya, and Orpon. Yeah. So is it clear to all? Shreya and Moha, Shushmita. Are you guys done with it? Okay, fine. So this is the thing. So we go always for, there is a blue property. We write blue. Best linear unbiased estimator. But if this linear assumption is relaxed, then what will happen? So we go for non-linear estimation process. Okay, fine. So we will have a non-linear estimation process for the time saving. So for time saving and for you guys, I have already written the code. When the previous class was going on, I have written the code in a word file. I have saved it in a word file. I will just explain you the code. And I tell you that I also told you yesterday also that you are going to be a data scientist, not a software developer. So in today's date, it is not a huge thing or not a massive thing for you guys to remember the code, to write the code, to do everything. All you need is to understand the models. These models, you guys will be getting paid for these types of thinking. You guys will not be getting paid for writing the code, because a software engineer will write a code better than you, because he or she is studying computer science from the very beginning, from his college days, and you are studying economics or commerce or management or other things in from your college days. So there is a huge gap between us and software developer or a website developer, because they used to write code. Their main work is to write code or to develop a code. But you guys are going for a to be a data scientist, and what should you do? You guys will be paid in the industry for these types of knowledge, that you have the knowledge. You have the knowledge that I will not this from the data I can just go for linear is regression or non-linear regression. Okay, so I will give you the code, do not worry. So what I do, I basically open my Python. Okay, the Jupyter notebook. Okay, so I have to upload the data. What was the name of the data? The data name was SPLINE regression. Okay, I have to go here, and I have to, on the desktop, I can go here, I can go to the Spyland regression, and I can open. I click to upload. It is already uploaded, so I do not have to upload again. So if you are new, you will have an option here, upload. You will just click on upload, and the data will be uploaded. Okay, fine. So it is telling me that already a file named Spyland regression is there. So do you want to replace it? If I click on overwrite, it will re-upload again. Okay, fine. So what I do, I basically view the data first. We just go to the data first. Okay, so I go to the data first. So you can see there, which is the dependent variable here. Can you tell me which should be the dependent variable here? Study
Score.
hours, score, exactly. And the independents are study hours,
Study hours, sleep
sleep
hours,
hours,
and
and
IQ.
IQ. Fine. So I will go for a scatter plot. I will go for scatter plot, and I will view that what type of scatter exists between score, study hours, sleep hours, and IQ. Then I will go for spyline regression. Okay. So basically, the thing is that I just open my notebook, a script, a Python script, and I just open this spyline regression code. I have written this. I will give you to guys. Okay, do not worry. You do not have to take screenshot or any other thing. Just understand right now. I just when your previous session was going on, I just written this code for you guys. I will give it to you. Okay. So first two lines I just copy, and I just go to the Python notebook and call. What are the interpretation of these two lines? Can anyone tell me what are the interpretation of these two lines? What we have done?
Sir, we import NumPy because just to deal with the numbers related things,
Yes, yes,
and pandas because data related things.
very good. So we just import the pandas library and give it as a name as pd, and numpy library and give it as a name as np. Fine. Now what we will do, we will import another library that is known as statsmodels.formula.api. Yes, for running a regression. For running a regression. Yesterday we have done with statsmodel.api, but today we will write statsmodels.formula.api. Both of these are enough for regression. Okay, you can write statsmodels.formula.api also, or you can import statsmodel.api also. There is no difference. Some differences are there, but for running a regression, both the libraries will work well. Okay, the statsmodels.formula.api will also work well. The statsmodels.api will also work well. We import the statsmodels.formula.api as smf. Fine. Now what we do, this is the another library we have taken up. Fine. Now we will read the data. Okay, just you guys tell me the code. I will name the data as data. What will be the code if I want to read the data? Data equals to, what should be the code?
pd underscore read
pd dot read
pd dot read underscore
excel. Fine. And in a bracket, what will be there?
the title of the file dot xlsx.
Spyline dot xlss. So I have already the code here. Data equals to pd dot xlsx. Okay, I will just copy and I will just write. Okay, I'll just give the code here. You can see the code. Data, we have given the name as data pd dot read underscore excel spyline regression on excel dot xlsx, and we have to view. If we want to view the data, we have given data dot head. Fine. We will just see. You can see the data. The first 5 rows appears. The score, study hours, sleep hours, and IQ for this data set. The first 5 rows appears, and after that we want scatter plot. So for visualizations, which library should we import? For data visualizations, which library should we import?
Matplotlib.
Very good. Matplotlib.pyplot. See, import matplotlib.pyplot as plt, and we will import another library also. Let me just make this a little bit bigger. So guys, you can just see from here. Okay, so what is this? Import matplotlib.pyplot as plt, and this is also another library. Import cborn as sns. This is also another library. Cborn is also used for visualizations. Okay, so I will go with import by matplotlib.pyplot as plt and cborn as sns. These two code I will also just copy and paste. Okay, here. Okay, so this is matplotlib.pyplot is used for what? It is used for visualizations. Cborn,
Visualization.
cborn is also used for visualization. So I will
Sir,
import
if
this.
I ignore Seaborn here, then what will be the problem?
If you ignore cborn here, there will be a problem because I want to generate a higher degree of scatter plot. I want to generate a higher order of scatter plot. So matplotlib.pyplot have some extent, will work to some extent. But if you want to generate, someone is is there any mic coming out? Okay, so if you want for matplotlib.pyplot, it will work to some extent, but cborn is more powerful. Cborn is more powerful for this data
So
visualizations.
you basically use this
Hmm.
library for correlation heat map in the previous
Yes, yes,
class.
yes, yes, correlation heat map. So if you want bar chart, if you want the if you want bar chart, if you want other pie chart, matplotlib.pyplot is enough. But if you want correlation heat map, if you want some higher order scatter plot, so you have to import cborn. Okay, matplotlib.pyplot will not only work. Okay, okay, fine. After that, I want a pair plot, not a scatter plot. I want a pair plot. What is basically a pair plot? A pair plot is basically that how many columns do you have? You can see how many columns: score, study hours, sleep hours, IQ. What is your dependent variable? Score. And what are your independent variables? Study hours, sleep hours, and IQ. Fine. So pair plot is something like, what is a scatter plot? What does a scatter plot show? What does a scatter plot show? A scatter plot show relation between two variables. Yes or no? Two variables. But if you generate a scatter plot, you can generate between score or study hours. You can generate between score or sleep hours. You can generate between score or IQ. But if you want the scatter plot of score study hours, score sleep hours, score IQ, both the three in a single diagram. In a single diagram means the diagram will be different, but in a single code. If you want both the three of the correlation, the three of the scatter plots in a single code, so you have to go for pair plot. Scatter plot will not be okay. Scatter plot, what we do is scatter plot. If you want the scatter plot between score and study hours, you can get. If you want the scatter plot between score and sleep hours, you can get. If you want the scatter plot between score and IQ, you can generate it by different codes, and you have to write three times. The code you have to write three times. But if I want to write a single code and I want to generate three diagrams which will show a scatter plot between score and study hours, a scatter plot between score and sleep hours, a scatter plot between score and IQ. So I will use pair plot, and this pair plot will be used. And when we will use pair plot function, which library will be using? The cborn library. The cborn library, that matplotlib library.pyplot, you can go for scatter plot. If you want to generate the scatter plot only of score and study hours, matplotlib.pyplot is okay with it. But if you want to generate the study hours, IQ, and the sleep hours, all the three with score, then you have to go for matplotlib.pyplot. Sorry, cborn.sns as sns. Okay, so you can give the name as sns or smp, anything, but the you have to go with cborn. Okay, now we write. See what we write. We write sns dot, what kind of plot we are using? Pair plot. What kind of plot? Pair plot. Our data, what is our data? What is the name of our data set? It is data. So we have given data, comma, x vars. Do you know what is x vars? X underscore vars means x variables. X variables. Okay, and we have given the y vars. We have to see the pair plot between x variables and the y variable. Okay, and we have given that if column not in score, because you need a scatter plot between score and score. Do you need that? Do you need a scatter plot between score and score? No. What do you need? You need a scatter plot between score and study hours. You need a scatter plot between score and sleep hours. You need a scatter plot between score and IQ. Do you need between score and score? No, you do not need. That is why we have written not in score. We do not need for score. Just I will run this code and you see. You see. How many scatter plots have been generated? Just see how many scatter plots have been generated. What is the y-axis for all the scatter plots? Can you answer? What is the y-axis for all the scatter plot? What is the y-axis thing? What is the x-axis for all the scatter plot? I am sorry.
Four.
Score. You can
Four.
see the score is written at the bottom. The score is written at the bottom. Now if you go for scatter plot, if you go for a normal scatter plot, you have to write a long code, and a long code how many times? Three times. You want to generate for study hours, you want to generate for sleep hours, you want to generate for IQ. But I have written a single line code. I have written a single line code using the SNS library. This is important. Which library I am using? SNS library. And what type of plot? It is known as pair plot. It is known as pair plot. So I am using a single line code, and with this single line code I am getting the three types of scatter plot. The first scatter plot is between score and study hours. The second scatter plot is between score and sleep hours. The third scatter plot is between score and IQ. Now you guys tell me that what type of relation exists between score and study hours. First tell me this. What kind of relation exists between score and study hours?
Strong positive correlation.
Strong positive correlation, and totally there is a linear trend, you can see.
Yeah.
Yeah, there is a totally linear trend because the data goes strongly follows strongly linear trend. So there is a strong positive correlation between study hours and score. We can see that there is a strong positive correlation between study hours and score. Now tell me, what is the correlation between sleep hours and score? How can we interpret? How can you interpret? Can anyone interpret this? Anyone? What is the relation between score and sleep hours from this data set? Can anyone tell this? No, no one can tell this. Sir,
Sir,
positive,
এটা
negative, yes,
পজিটিভ মনে হচ্ছে।
yes, one kind of positive, but there is a very, very contradiction. What kind of contradiction? As you can see, there are some pupil whose score is very low, but sleep hours are very high.
হাই।
There are some pupil whose scores are very high, but sleep hours are very also high. So we exactly cannot tell that there exists a linear trend or not a linear trend. So what we can do, when you just see this thing, what we can do for when we are just going for score and study hours, what is our, what it should look like? What is the regression trend? Score and study hours, positive, totally positive. Our regression line should look like this, no problem. But when we are not using study hours, we are using, when we are using what, we are using sleep hours. So we can say that there is a linear trend. Can we say that? No. Can we say that? No.
No,
So,
sir.
so what we will do, this is totally a non-linear estimation. This is not a linear estimation. So what can I do? I can, I can categorize pupil with their sleep hours. There are some pupils who sleep between 0 to 5 hours. There are some pupil who sleep between 5 to 10 hours. And there are some people who sleep between greater than 10 hours. And what you can do, you can run three regression models. You can run three regression models. Can you? For 0 to 5 hours there are some people, you can run a regression model, you can get the relation. For there are some people who sleep between 5 to 10 hours, you can run a regression model, you can get the data. For some people who sleeps greater than 10 hours, you run a regression model and you get the data. And for 0 to you can run three regression models. But what spline regression do, suppose this is my 5 and this is my 10 and this is my suppose 15. What spline regression do, it basically runs it basically, these are known as knots. Knots. Knots means the category. Knots means the category. The first category belongs to those people who sleep between 0 to 5 hours. The second category belongs to those people who sleep between 5 to 10 hours. And the third category belongs to those people who sleep greater than 10 hours. So these are nothing but these are knots, or more specifically, these are categories. So this is a totally nonlinear estimation process. So what spline regression do, you know? Spline regression used to regress these three types of categories, particularly for 0 to 5 1, 5 to 10 1, and greater than 10 1. And then it fits a line. Suppose when we have you ever do you know what is a cumulative polygon? Do you know what is a cumulative
Yeah.
polygon? How do we generate cumulative polygon? By drawing histogram first, and on the bottom and at the middle
Then
of that is,
add the,
yeah,
yeah,
at the middle of the histogram we used to draw points and we used to join that as it.
yeah, yeah.
So just like that, spline regression fits three regression models differently. Suppose for 0 to 5 hours the regression line is like downward sloping. For 5 to 10 hours the regression line is upward sloping, and for greater than 10 hours the regression line is horizontal. So you have three regression line on different. This is for 0 to 5 hours, this is for 5 to 10 hours, this is for greater than 10 hours. There are three regression line for three different categories. No, this doesn't spline regression basically do. Spline regression, what it does more than this. What it do, it do more than this. What it do, it basically regress these three categories and join them by a smooth curve. Suppose my regression looks like this. My regression line looks like this. Suppose for 0 to 5 hours, the points are like this. For 5 to 10 hours, the points are like this. And for greater than 10 hours, the points are like this. So what it do? It basically joins the curve. It basically joins the curve, and this becomes my regression line. This becomes my regression line. Now this line is linear. Is it linear? It is linear regression.
No.
No. So what type of estimation process is this? What type of estimation process?
Non-linear
Non-linear
estimation.
estimation process. So I am repeating again. This is a very interesting thing. What spline regression do? Spline regression, basically there are three types of category of pupil. One category of pupil, they used to sleep between 0 to 5 hours. One category they used to sleep between 5 to 10 hours, and one category they used to sleep between 10 to 15 hours. 10 to 15 hours. Now what basically regression do, what spline do? Spline fits regression for each and every one. Okay, fine. After that spline, what spline does? Suppose for 0 to 5 hours the regression line, the dots of the regression line are like this. For 5 to 10 hours the dots of the regression are like horizontal, and for 10 to 15 hours the dots of the regression are like this. So can you tell, for 5 to 10 hours it is downward sloping. For 5 to 10 hours it is downward sloping. So what does it mean? As sleep hours increases, score decreases. For 5
Decreases.
for 5 to 10 hours it is horizontal, means there is no relation. There is no relation. There is no relation. Those people who sleep between 5 to 10 hours, they do not have any, they possess any kind of relation between score and sleep hours. And for the people who are having 0 10 to 15 hours, the regression, suppose it looks like again downward sloping. That means again if the sleep hours increases, what happens to score? The score decreases. So this, after doing this, what spline do? Spline fits a curve by joining this point, and this becomes your regression line. This
Sir,
becomes your, yes, regression
sir,
line.
how many basically how many categories
Hmm.
spline regression can deal with together?
It is totally a software generated process. When you give the data to Python, Python will generate, or you can also give some types of categories, but it is totally a software generated process. When you will get the result, you can see that how many types of how many categories do it build. In when you are using logistic regression, when you use logistic regression, status shows you some iterations, you remember, status shows you some
Yeah.
iterations. So how
Hmm.
many, up to how many iterations data will go. So this is totally software generated. Software will generate up to that iteration where it is best possible. So in this case also, if I give, suppose I give to Python that there is a 0 to 20 hours sleep hours, I just give this data to Python. There is a 0 to 20 hours of sleeping hours. Python will generate category on the basis of this. Python can generate 0 to 5 1, 5 to 15 1, and 15 to 21. Okay,
Okay.
thick, basically. Okay, now what we will do, we will go to Python. Up to this, is it clear to everyone? Is it clear to everyone? Okay, others?
But engineers found out that curve in
Hmm.
obviously not using this software.
No, 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 no. That time, this software was not available. Simon Kuznets inequality data. That time, these softwares were not available, and Kuznets. That was a long process. Those days, it was very tough to generate a inverted U-shaped curve. Okay.
Okay, sir.
Yeah. Basically, today we are getting, you guys get p values, no? You guys get p values though when you run a regression or anything. I am telling you that 10 years ago, okay, 10 years ago, hmm, there was no p values. There was no p values. There was no p values. How can you interpret? You also get a t value. Have you often looked upon that? You
Mhm.
get a t value. And when you used to do sums in our PG or UG days, we, in our question paper, a tabulated t and calculated t was given.
Yeah.
Yes,
1.96,
1.9,
2.58.
exactly. And in previous days, when people run a regression, and after that, when they used to how to, whether to accept the null hypothesis or whether to reject the null hypothesis, they used to compare the t values. They do not get the p values. In today's date, softwares are becoming very powerful, and they are giving the p values. I remember one of the teacher from Jadavpur University, a madam from Jadavpur University. His name was, I think her name was, I couldn't.
Malavika ma'am?
Malavika Roy, I know, but her name
Oh,
I,
AD ma'am. AD ma'am, sir?
I think so. So he
Original name.
she was in once she was in our university, and then she taught us the GMM model. Okay, the GMM model, Gaussian mixture model. Okay, GMM model. So when she was teaching us the GMM model, she told us that in today's date, you guys are so lucky that you guys get calculator, you guys get softwares, and you just run a regression and all that. She was telling that when they were students, they used to calculate the regression coefficients beta. Okay, we used to get the beta coefficients from where? I am just going for stata or Python. So you remember the formula, I think, for the estimation process, summation covariance of xy by, so
Yes.
yeah, in that process.
Sigma X, Sigma Y.
Yes, and not only that, she was telling that in those days calculator was also not available. Calculator was also not available. They used to do with wall calculator. There was a thing named as wall calculator. It was like a wall clock. As we see wall clock, it was like a wall clock, and the wall calculator was pasted in the wall, and you have to use that wall calculator to calculate that. and they used to calculate a lot of data for a regression equation. They used to fit a regression equation by using that data, after adding those, dividing those, multiplying those, and after that they used to get the value of beta. So in today's date it is being very easy for us to get
Yeah.
all this. So however, so now let's go to Python, and now what we will do, we will first run a OLS model. We will run a OLS model. We go to Python, we will go for a OLS model. Okay. In this OLS model, yesterday I have done a OLS model, but in a different manner. I will do a OLS model in a different manner. What is the difference? Yesterday you have stored score in Y and study hours, sleep hours in X, and then you run a OLS model. But today I will not do that. Any one of you have learned R, I think. In R also we use this tilde sign for OLS. Okay. In R programming also we use this tilde sign for OLS. So in this case we name the model as model equals to smf.ols. And what type of library we are using while running OLS? It is the SMF. What is our SMF? SMF is the statsmodels.formula.api. This library we are using for our OLS. And what is our dependent variable? Score tilde study hours plus sleep hours. I am just removing IQ for right now. Okay. Study hours plus sleep hours. And what is our data? Data is what is the name of our data? So data equals to data, because our name of our data is actually data. Okay. So if the name of our data is df, so what we write? Data equals to df and dot fit. Then we run this. What should be the command next for generating the ANOVA table? It should be model dot summary, opening a first bracket and closing a first bracket. We just go for run, and this is the OLS estimation. So can you interpret that study hours and sleep hours are significant or not?
Yes, sir. Study hours is significant, obviously,
And sleep hours
and sleep hours is also.
also significant. Okay, so both of them are significant. What is the Darwin Watson value? Is there any autocorrelation
We
problem
are
or not?
equal to Q, so there is no autocorrelation
Exactly.
problem at all.
And from the
And the
Jarkivera,
Cherky-Vera value is near equals to 1, so
null
obviously
hypothesis
there is
accepted or alternative hypothesis accepted? The null
null
hypothesis.
hypothesis is
Though
accepted.
our data, our residuals are following, are normally distributed.
Null distribution.
Okay, fine. So now what I will go, I will go for another OLS model. Just see. In this OLS model, score is the dependent variable, study hours is the first independent variable, and study hours asterisk asterisk 2. What does it mean? Can you say? What does it mean?
Yeah, study hours times squared, মানে study hours
Exactly,
squared.
exactly. And again sleep hours and sleep hours square, means my equation will be like this. Means my equation will be like this. Oh, sorry. What will be my equation? My equation is
Parabola type
y equals to alpha plus beta 1 x1
x1
plus
plus
beta 2
beta
x1 square
x1 square plus
plus
c.
beta 3 x3, sorry, x2 plus beta 4 x2 square. What is x1?
Oh,
Study
x1
hours.
is study hours.
X1 square means more study hours. Study hours square means if the study hours doubles, you study for 4 hours a day, but if you study for 16 hours a day, what will happen to Y? If you only predict that study hours only impact Y, that may not happen, because my scatter plot is showing something different. So study hours square means if you study for 3 hours a day, then what will be the square? 9 hours a day. What is x2? Sleep
Mhm,
hours. And sleep
mhm.
hours means x2 square means sleep hour square, means if you sleep for more. If you sleep more, then what happens to your score? Fine. So we will go there. So here we have written study hours. So this is our x1, this is our x1 square, this is our x2, and this is our x2 square. So means we are just getting that if my model is not linear, if it is quadratic, it means it is non-linear. Then what will happen? I go here, I run this command. Now I will go for model dot summary. Just see. Are is study hours and study hours square significant? Is sleep hours and sleep hours square is significant or not? Just interpret. There is a very good
Yes.
interpretation. So if my study hours increases, what will happen to score? Will it increase or decrease? Tell me.
Decreases.
Study hours coefficient is 11.65. Positive
Decreases,
coefficient.
sir.
Positive coefficient. So if
No,
study
study
hours
hours.
increases, then score will also increase. Positive coefficient.
Oh, study hours squareটাকে আমি ভাবছি না,
Okay,
sorry.
study hour square. If study hours increases more, if you study for more, then your score decreases,
Will
because
fall down.
okay, because there is a negative coefficient, so we should not study for more. Now if sleep hours increases, then my score increases. But if sleep hours increases for a more, if it is squared, if the variable is squared, if it increases for more, then what will happen? It will decrease, my score will decrease. And all the coefficients are significant or insignificant?
Significant.
All the scores are significant. Now tell me that if I study hard, then if I study more, then my score will increase. But if I study more than enough, if it is being enough, then I am also studying, then what will do? My score will decrease because there is a negative coefficient. Sleep hours, it is a positive related. If I sleep, then there will be if my sleep hours increases, my scores will increase. But if I sleep for a long time, I sleep for 24 hours a day, I sleep for 12 20 hours a day, then what will happen? Then my sleep hours, if it is 20 hours a day or 24 hours a day, then my
Then
score
the
will
score will
de-
automatically
decrease.
fall.
Now go for the Darwin Watson autocorrelation present or not? No, it is
No,
clearly equals to 2. And Jarki Vera null hypothesis accepted because it is
less
0.63.
than 1.
Okay, fine. Now we go to the next thing. Now we go to spine regression. Spine means spline regression. Okay, we will copy this code and we will just I'll just explain it to you. First let me copy this code. You do not have to take screenshot, I will give this to you guys. Okay, do not worry, and I will give the full recording of this class. You do not have to get this also, I will give the full recording of the class.
Sir, there were three independent variables.
Hmm, there were three. Okay, in this case
Yeah.
no, I am just doing a spline regression. No more OLS, no more OLS. I will go for, oh, in this case you want, if you want to include the other variable, you can. You
Yeah.
can, you can. There is no problem. Okay, because I have included these two variables because think IQ square I can include. There is no problem. The pupil with high IQ can do. You can do. I have shown with you two variables, only two variables. But if you want, you can go with IQ square. You can go with IQ square. No problem in that. Okay. So suppose I am just this is another Patsy. This is a sublibrary and I am importing D matrix from this sublibrary. Now I will run a spline regression. Model spine smf.ols. Spline regression is not other type of regression. It is basically as ordinary least square. It is not like I am doing a totally different types of regression like lasso or ridge. No, it is basically like OLS because we write the equation as y equals to alpha plus beta 1 x1 plus beta 1 x1 beta 1 beta 2 x1 square plus beta 2 x2 plus beta 3 x3 square. We write like this. Okay, so the basic thing is that I have written a wrong thing, I think. No, beta 1, beta 2, beta 3, beta 4. No, it is okay. Okay. Now, what we do, score is our dependent variable, study hours is our independent variable. Okay. Now, sleep hours. I just explained you previously that we will categorize between 0 to 5. Python will categorize. So what I have given here, see what, how me, no, what is the knots of me, knots, what is the knots, 6 comma 8. So I am telling Python that those people are sleeping from 6 to 8 hours. I am giving Python an interval. You have to give an interval to Python. If you want, you can give 5 to 10. If you want, you can give 10 to 15, the sleeping hours from 10 to 15. I am telling Python that check for those people who sleep for 6 to 8 hours. 6 to 8 hours. Why? Because this is the most prominent time we should sleep for. Okay. The most prominent time we should sleep for 8 hours or 7 hours or 6 hours. So I have given Python a interval. What is the interval? It is 6 to 8 hours. Okay. And what this degree means? Degree equals to 2 means I am not fitting a I am not fitting a linear regression. I am fitting a quadratic regression. Quadratic degree 2 means sleep hours. What will be degree 2? Sleep hours square. Sleep hours square. And include intercept equals to false. So I want to include a intercept. And what is my data? What is the name of my data? It is data, and I write fit. This is the most prominent thing. Most of the people, when we used to do Python for the first time, we used to forget the fit function. Okay, we never write the fit function. After that, if I do not write the fit function, Python will generate a very long error. And after that, we used to think that where is the error. After that, we saw that they are fit. So you do not forget to give this fit. So what is my dependent variable? Score. Independent variable study hours, it is being included. IQ is being included. And for sleep hours you are doing a spline regression. These are basically the same. Score tilde up to this is normal OLS. What you do up to this part, this is normal OLS. What you do? Y equals to alpha plus beta 1 x1 plus beta 2 x2. What is my x1? Study hours. What is my x2? IQ. So what is my Y score? Y equals to beta 1 x1 plus beta 2 x2. But I want to include sleep hours as a spline model. So in this case, I have to give the interval first. I have given 6 to 8. The people who sleep between 6 to 8. And what is the degree? The degree is 2. 2 means, what is the degree? The degree is 2 means sleep hours square. And what is my intercept? I have given an intercept. Now I will run this command. Now see. Now see. First interpret study hours. Have I applied spline to study hours? Have I applied spline to study hours? Yes or no? Have I applied
No.
spline to study hours? No. So,
No.
so study hours, is it p value is significant? So what it does? 5.3685. So it does it. What does it mean? It means that if study hours
Okay.
increases, scores also increases. Fine.
Four also increases.
IQ. Have I applied spline to IQ? No.
No.
So IQ is significant. IQ is significant. And what is the value of IQ coefficient? 0.1668.
Okay.
So means if IQ increases, it also
Score
the
also increases.
increases. Now here comes the sleep hours. Here comes the sleep hours data. You cannot never, do not ever interpret this part. Do not never interpret this part by the p value. Never. Because spline regression doesn't mean that you go and to interpret the each and every knots by their p values. No. What spline basically do? Spline basically, for sleep hours, spline basically generates a total amount of possible actions. Spline basically generates the total amount of possible actions. So for these sleep hours, the regression line is not linear. For these sleep hours, the regression line may be like this, maybe like this, maybe like this, maybe like this. So what Python does? Python basically gives you the continuous line. I am repeating, spline regression gives you the continuous line. Continuous line means, let me show you. Suppose for sleep hours, okay, first let me go for study hours. What will be the line for study hours and score? What should it look like? Positive?
Yeah.
Yes. What should be for IQ? It is also positive like this. But
Yeah.
what should be
The
for
slope is the
slope is positive, but what should be for spy line, what should be for sleep hours? You see that for sleep hours, the first coefficient is negative, the second coefficient is positive, the third coefficient is positive, and the fourth coefficient is also positive. That means spyline fits different regression. Spyline fits different regression with score. Means I have given an interval. What is my interval? 6 to 8 hours. The pupil who sleeps between 6 to 8 hours. So in this knot, spyline basically fits different regression. Suppose for what will be the slope for this first regression, first one. What should be the slope look like? It is negative. So what should be the slope look like? It should be negative. It should be like negative, and others are positive. So suppose my first one is the scatter plots, the regression line is like that, and others are positive, 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 positive. So I am just getting a positive, positive, positive. So do you know that with the value of slope, the value of slope is basically responsible for the diagram. If the value of slope is very high, then should it be flatter or steeper? If the value of slope is very high, should it be flatter or
steeper.
steeper? And if the value of slope is low, then it is flatter. So suppose
And
I'm just drawing for you. I will just draw it for you guys. For the first one, remember this thing. Remember this thing. For the first one, it was negative, then it was very high, it was very high, then it was low. Okay. So what will be my regression look like? First one, it was negative, and then it was very high. High means it will be flatter or steeper?
steeper.
Flatter or steeper? Steeper. So it will be like steeper, steeper, steeper. And then second one, it was little bit less, so it will be flatter or steeper? Little bit less. It will be
Little bit
something flatter,
steeper.
something flatter. From it was for 4, this value of the slope is 4,
Yeah.
and for 3 it will be something like this.
Hmm.
And now if I go to the last one, it was very low, 0.5. The value of slope is very low.
Yeah.
So what will be like this? It will be very much flatter. So this is my basically in this era, y axis means score, and in the x axis I write sleep hours, sleep underscore hours. So my regression beta 1 was negative, so I have given a negative line. Beta 2 was positive and very highly positive, so steeper line. In this section it was steeper line. Beta 3 was positive and high, but not as of beta 2. That is why it is a little bit flatter. And beta 4 is very much low. Beta 4 is very much low, so it will be less, largely flatter. So my regression line, if I join this curve by a smooth line, this is nothing but my regression line. This is nothing but my regression line. This is nothing but my regression line.
Sir,
Hmm.
sir, I have a question
Hmm.
regarding this time regression.
Hmm.
Why there are four categories or four types of coefficients?
It is totally system generated. It is totally system generated. System will give you.
Okay.
Okay, system will always give you.
Okay. Sir, can you please show the code again,
Yeah, yeah,
which
sure.
is
For sure, for sure.
yes. So, sir, why in this case the intercept is equal to false?
Hmm. Intercept equals to false means you want to include a intercept.
Oh,
Include
but
underscore intercept equals to false means you want to include a intercept. So see, here
acha.
is a intercept. There is a intercept value.
Mhm. আর স্যার বিএস
হুম
দেন ফার্স্ট ব্র্যাকেটের ভিতরে আমরা যেটা আর
হুম
কি করতে চাইছি রিগ্রেশন
হুম
এটা
হুম
লিখলাম, তো
হুম
বিএস
হুম
এখানে কি বেসিক্যালি মিন
বিটা
করছে?
বিটা 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 ভ্যালু বিটা
ও ও
beta beta of
বুঝেছি।
what sleep hours for the range
ইয়া
6 to 8. What should be the
হুম,
degree? If you write here 3, if you can give
then
here 3
if
also,
function,
then it will be cube function. And intercept, I will include a intercept. What is my data?
intercept.
The name of my data is data and dot fit.
Okay. But if I am not interested to include an intercept term, then what will be the
Include
code?
intercept,
Intercept is
you do
equal
not
to
have to
true.
give that code, or if you write include intercept equals to true, you do not have to give that code. What you do basically, you do not have to give, write that portion. Okay.
Okay, sir.
So what the thing is that in normal regression, we assume that 1 unit increase in a independent variable has the same effect on score for everyone, but in real life this is not always true. Now suppose we have seen the graph scatter plot, and we have introduced knots. I am again repeating what knots are. Basically, knots are just points where we allow the relationship to change its behavior. Knots are point where we allow this relationship to change its behavior. In this case, which are the knots? Can you tell me? I will mark it with red line. This is the first knot. The behavior is changing. Yes or no?
Mm-hmm.
This is the second
Yeah,
knot. This is the second knot. The behavior is again changing, and this is the
it
third
is
knot.
changing.
This is the third knot. So
Basically, at the source are changed.
yes, so basically there are, this is the first knot, one, two, three, four. So the knots are
Right.
basically where the slopes are changing. Very good. The slopes are changing, or my curvature, or the relationship behavior. In this case, the behavior was negatively sloped. But in this
Yeah.
knot, the relationship is positively sloped. In this knot, this relationship is positively sloped, but a little bit lower. And in this knot, the relationship is a totally very low, positively sloped. So knots are basically like this. Okay.
Yeah.
And so always remember one thing: spline regressions fits different curves in different ranges but joins them smoothly. Different curves. This is the first curve, this is the second curve, this is the third curve, this is the fourth curve. So this is the first range, second range, third range, and this is the fourth range. But then it is joining them smoothly, and we get a regression line. Okay. Is it okay with all you guys? It's a very important, very interesting topic. I thought I should tell you this spline regression. So this is the what is, if the first always the regression line will look like this, it is not true. From a layman's view, what you can just interpret that sleep hours increases, score will increase or decrease. From a layman's view, you do not know economics, you do not know Python, you do not know statistics, anything. From a layman's view, if sleep hours increases a lot, score will decrease because I am going to sleep all the time. But what spyline does, it basically fit different line. This is a first range line, second range line, third range line, fourth range line, and it then joins them. Okay, check the Darwin Watson, guys. Okay with the Darwin Watson, close to 2, no problem. And Jarki Vera,
Close to 1.
yes. Is it okay for you all? Have you any type? Do you have any types of question? Gulsanara, Moha, Shreya, Shumit, Hushmita, and Orpon.
স্যার,
Hmm.
স্যার আপনি যে এখন
Hmm.
যেটার ওপর
Hmm.
পড়ালেন এটার উপরে
Hmm.
আমার কোনো কোয়েশ্চেন নেই, বাট আমার দীপ্তরূপ স্যার যে আজকে যে
Hmm.
এক্সাম্পলটা
Hmm.
দিয়ে করাচ্ছেন
Hmm.
ইনকাম
Hmm.
এক্সপেন্ডিচার ওই রিলেটেড একটা কোয়েশ্চেন আছে
হ্যাঁ হ্যাঁ বলো
যে
বলো, ইয়েস ইউ ক্যান সে।
sir,
হুম
why we always think that the expenditure is always dependent on income?
হুম
Basically, from UG section, we have
হুম
learned that C is equal to capital C is equal to C bar plus capi MPC times Y. That means income.
হুম